Here's an example of magnetic forces between current-carrying wires. Wire 1 carries a current of 15 amperes from the bottom to the top of the page. Wire 2, parallel to wire 1, is placed 5 centimeters to the right of wire 1 and carries a current of 5 amperes in the opposite direction, from the top to the bottom of the page. Wire 3 carries a current in the same direction as wire 1. The net force on wire 3 is 0. Where is it? So the first thing we're going to do is draw wire 1 and wire 2 5 centimeters apart, with wire 1 carrying current towards the top of the page and wire 2 carrying a current towards the bottom of the page. We need to figure out where wire 3 would be. And for that, we need to figure out whether wire 3 would be on the right side of the picture, in the middle between the two wires, or on the left side of the picture. Wire 3, we know, carries current in the same direction as wire 1. Now, two wires that carry current in the same direction attract each other, and two wires that carry current in opposite directions repel each other. So we know that wire 3 will be attracted to wire 1 and repelled by wire 2. If wire 3 was on the left side of the picture, the force that 1 exerts on 3 would be to the right, and the force that 2 exerts on 3 would be to the left. So we would have two forces in opposite directions. However, wire 1 carries more current than wire 2. So if we're closer to wire 1, the force that 1 exerts on 3 will be greater than the force that 2 exerts on 3. These two forces cannot cancel on the left-hand side of the picture. Between the two wires, the force that 1 exerts on 3 would point to the left, and the repulsion that 2 exerts on 3 would also be to the left. So the two forces point in the same direction. They cannot cancel between the two wires. On the right-hand side of the picture, the attraction that 1 exerts on number 3 would point to the left of the picture, and the repulsion that 2 exerts on 3 would point to the right of the picture. So we have two forces pointing in opposite directions. Also, we are further away from wire 1 than we are from wire 2. So the greater distance from wire 1 could compensate for the fact that the current in wire 1 is bigger. So there's a good possibility that the two forces can cancel on the left side of the picture, and this is where we'll place wire 3, like so. Then we draw the forces on our picture. The force that 1 exerts on 3 is an attraction, and the force that 2 exerts on 3 is a repulsion. Finally, we also have to explain that wire 1 carries more current than wire 2, so wire 3 must be further away from wire 1 than wire 2, so that the forces on it can cancel. I'll leave the picture up there, and I'll call the distance between wire 2 and wire 3 x. We want the force that 1 exerts on 3 to be equal to the force that 2 exerts on 3. That force will be given by ILB sine theta, where theta is the angle between the magnetic field exerting the force and the wire that is feeling that force. For example, if you're talking about the force that 1 exerts on 3, wire 3 feels the force, and wire 1 is the one that is creating the magnetic field. So it's going to be I3 LB1 sine theta, where theta is the angle between the magnetic field of wire 1 and the current I3. In order to find the angle between the magnetic fields and current number 3, we need to draw the magnetic fields of our two wires. For that, we put our thumb along the current. So first, for example, put your thumb along current 1, and then you see that your fingers go into the page on the right hand side of the wire, and they go out of the page on the left hand side of the wire. So the angle between B1 and I3 will be 90 degrees. Similarly, if you put your thumb along I2, you see that your fingers go into the page on the left hand side of the picture, and they go out of the page on the right hand side of wire 2. So the angle between current 3 and magnetic field number 2 is also 90 degrees. And that allows us to write the forces as I3 LB1 sine 90 has to be equal to I3 LB2 sine 90. Obviously, this simplifies. There's I3 on both sides, there's the length on both sides, and the angle between I3 and B1 is the same as the angle between I3 and B2. So finding the place where the two forces cancel is equivalent to finding the place where the two magnetic fields cancel. We will replace B1 and B2 with the formula for the magnetic field of an infinite wire. The magnetic field of B1 is mu0 I1 over 2 pi R1, and the magnetic field of B2 is mu0 I2 over 2 pi R2. Now, the constants mu0 and 2 pi on both sides cancel out. I1 is 15 amperes, and the distance between wire 1 and the position of wire 3 is 5 centimeters plus x. So 0.05 plus x in meters. The current in wire 2 is 5 amperes, and the distance between wire 2 and the position of wire 3 is x. We now have one equation with one unknown, which we can solve. If we divide both sides by 5, we get 3 times x is equal to 0.05 plus x. We can solve for x and get 2.5 centimeters. So wire 3 is 2.5 centimeters to the right of wire 2. Here's the full page solution. Spread the joy of physics!